that is as dark as black paint, or close to it. Hard to believe that if you took the moon and wanted to compare it to an object on Earth, the nearest thing you could find would be asphalt, a parking lot. So if some insane developer went to the moon and paved it, turned it into an entire parking lot, paved it with asphalt, the truth is it would be no darker than it already looks in the night sky. It's got a reflectivity of only 12%. It bounces only 12% of the sunlight that hits it. Black paint is about 10%, so it's pretty darn dark. And speaking of that, all of this has taken us to right now, the midpoint of this lunar eclipse. We're right in the middle of it now, and so, Duncan, we can look at it and decide whether there is any asymmetry or irregularity. What do you think? What are we looking at?
Well, first of all, I think it's absolutely beautiful, and the image we're getting back here now is stunning. And as I say, I'm deep in the bowels of the Mayflower Studios here in Soho, and I can't see outside, but what I can see on my little laptop here is this wonderful image. It looks to be pretty even to me, Bob.
It does to me too. A little bit of a surprise that we're getting such a normal eclipse, since we've had such a spate of volcanoes erupting, and normally that'll make it for a blacker eclipse than usual, since the light that's hitting the moon, we said this earlier but it bears repeating, is the light from the edge of Earth. So that if you were on the moon now looking back, you'd be seeing no sunlight, because the sun is behind the Earth in the sky. The Earth is just inky black, but it's surrounded by a red ring of all the world's sunrises and sunsets, and that ring of fire is what's illuminating the moon at the moment. But that ring doesn't have to be symmetrical. Very often, if part of Earth is more polluted, cloudier, have volcanic eruptions, you'll get one section of that ring that'll be darker than the rest, and therefore the light that's bent or refracted onto the moon's surface will make for one part of the moon to be darker than the rest. Instead, we're seeing a pretty darn even redness on the moon, and that means that despite these volcanoes and despite all the bad news in the newspapers, Earth is normal.
Pretty amazing shot, isn't it? Look at that.
It's gorgeous. We're now at mid-eclipse, just absolutely stunning. The moon is going to shift its position. You know, Duncan, you were talking about the background stars. We see one just to the right of the moon. Yeah, there's another star above it. Maybe we should point out that the moon moves through space, one diameter per hour. The moon is a half degree in size. And that surprises a lot of people, because most people remember the moon as being larger than it really is. I found that if you ask friends, and just ask people who are not astronomers, to rate the size of the moon, and of course, since people don't know how to use degrees in their mind, you could put the question this way. If you were to stack full moons, one atop the other, how many moons do you think it would take to stretch from the horizon, the skyline, to straight overhead, the zenith? How many moons would it take? And that's a way for people to assess their recollections of the size of the moon. And most people, I found, will say something like 40 or 50 or 60 moons. The real answer is 180 moons are required to stretch from the horizon to the zenith. Since there are 90 degrees in that span, it means the moon must be half a degree. Same size as the sun, and it's another astonishing coincidence, if you believe in coincidences, that we only have two disks in our skies. We were just talking about how both the sun and the moon appear perfectly round. Those are two of the only round shapes we ever commonly see. And these two disks are both the exact same apparent size. That's why the moon so perfectly fits over the sun for those spectacular solar eclipses. It's not larger, substantially larger. It's not smaller, and if it is, sometimes during the far part of its orbit, it's just barely smaller. They're really the same size disks, and if either the sun or the moon were nearer or farther or larger or smaller, you wouldn't have that. And we didn't used to have that, because the moon used to be closer to us, And since it's spiraling away from us at the rate of 1.5 inches a year, we're not going to have it in the distant future. So it's only really for now, when humans are on Earth, that we have the moon and the sun being the same size in our sky. Another thing that people used to think was almost a sign, a divine sign, and a lot of people turn to astronomers for their religious beliefs. For some reason, Duncan, I know you've had this as well. People think astronomers have some sort of extra handle on the nature of the universe, and
I wish I did.
People always are trying to figure out whether the universe has some divine plan or whether it's random, and people often look to astronomy for that. And they used to think that one sign of a strange divine plan rather than a coincidence is the fact that the moon spins in the same period in which it goes around us. Its orbital period is 27.32166 days. I have to remember these things exactly. And its period of rotation is the same thing, 27.32166 days. And people would say, well, what are the chances of that happening? But now we know that even though the sun-moon same-size business is really either an amazing coincidence, there's no reason for it, but this other business isn't, because we've found only in the last few decades that every moon of every planet has the same spin rate as its orbital period around its parent planet. Or put another way, every single moon has one side that faces its parent planet. So our moon is not the oddball. It's not an oddity. Tidal forces have done this to absolutely every moon in the solar system. So there it is. There's the same features that we always see, because that's the side that always faces us.
I think that's a really interesting point you raised there, Bob, because it's one of those points that as we learn more and more, as we learn more about the universe around us, what once appeared to be unique and special actually perhaps isn't as unique or special as we thought it was or wanted it to be. And the same goes with things such as planets, exoplanets around other stars. It's incredible to me to think that 15, 20 years ago we only knew of 9 planets around our sun. Now there's a plethora of them out there. I think, getting on to close to 1,000.
That's right. Even though we lost Pluto, the others have more than made up for it.
Yeah, exactly. But we're getting this. I'm just seeing the feed now from Dubai, the live feed from Dubai here, and it's absolutely stunning. It looks like we're right in the darkest part of this of the Earth's shadow there. It's beautiful.
We're right at mid-eclipse. Now, what we're going to have our next guest on, and I hope you'll stay with us, Duncan, because you will understand her since you're both from the same part of the world. We won't need the subtitles. We've been running subtitles so far over the images for your British accent, but you two will not need it. We're going to have Lucy Green, who is a noted astronomer, expert on solar astronomy. We're going to have her on in 10 minutes from now, and we're looking forward to that as well, as we have just now passed the midpoint of this live lunar eclipse. Fantastic. Duncan and I, this is Duncan Kopp, a astronomer in Britain. I'm Bob Berman here in upstate New York. Lucy is also, who's going to join us, is also in Britain. We'll have her on in about 10 minutes. And we want to thank the people who've made this possible. A lot of people had roles in this. First and foremost, there is SLU. I hope you're watching this on eclipse.slu.com. And it's SLU whose technical work is making this live eclipse possible. And we also want to thank Paramount for sponsoring it, and Google for presenting it as well. And again, if you want to see more celestial things, live astronomy, definitely click on the Google site, or go to slu.com, and there you'll find a way to become a member and see live astronomy all the time instead of just during the eclipse. So, what are your thoughts? What is this making you feel, Duncan, seeing this?
Oh, I think it's beautiful. I mean, it's just stunning. I mean, again, as I say, it's one of those events that makes you appreciate that we do live on a rock, and day-to-day life occurs, but once in a while you look to the heavens and something happens that makes you. But it puts things in perspective for me. And as I say, the feed here from Dubai, the telescope in Dubai, is just wonderful. It's interesting you were talking about eclipses. When I was working with the Houston Symphony for the projects I did with them, it's called The Planets and HD Odyssey, and you were talking a little bit about that earlier. One thing that we did is we went back and looked at a lot of data from some of the spacecraft that went to other planets, and one of them, Cassini, that has had the most successful mission. It's breathtaking, the images, is in orbit around Saturn, the ringed planet, which is beautiful. But Saturn has this entourage of moons, and Cassini, the spacecraft, has been able to capture these movies as these moons dart in and out of Saturn's shadow. So these moons that orbit Saturn are constantly going through this eclipse cycle. Of course, we only have one moon, but the outer planets, the gaseous giants, Jupiter, Saturn, Uranus and Neptune, they have a whole suite of moons, and it's wonderful to watch this sort of celestial dance as these moons dip in and out of the shadow of their planets that they orbit, and pulling some of those images together and setting them to music, and it's almost the harmony of the spheres. And the Houston Symphony obviously perform Holst's The Planets, and Holst had no idea that these worlds existed when he wrote his music, and so it was a joy to be able to have that opportunity to put these images to the music.
Well, how would one obtain that? Is it available?
Oh yeah, it is. It is. I mean, there are a number of places in the US where various orchestras are going to play the Planet Suite to the visual presentation that I made for them. But if you wanted to get hold, we made a DVD actually. We made a DVD and a Blu-ray of the live performance. So you see all the pictures that I use, and you see and you hear the music as well.
So what is it called again? How would one find it?
It's called The Planets, an HD Odyssey. And I guess the best way is to go to the Houston Symphony, their webpage, and it's www.houstonsymphony, which is all one word, .org, O-R-G, and there's a little icon there of Saturn, and if you click on that, and if you wanted to get hold of the Blu-ray or the DVD, you'd be able to. But we were able to plunder all these beautiful satellite images, and you realize that what's happening now live in front of us is not unique to the Earth at all. In fact, all the time throughout just our solar system, there are constant eclipses as moons and asteroids and ring particles move in and out of the shadow of the various planets that they orbit. So it was a wonderful. It was just very evocative, I think, to put those images to music, and to think that Holst really at the turn of the last century had no idea that these bodies existed. And we actually, that there's a sort of a bonus DVD that you get if you buy the if you buy the production. And I went back to the Jet Propulsion Laboratory there in California and interviewed a lot of the scientists and the engineers who built these spacecraft, and they tell the most wonderful tales of what it took to construct the spacecraft, send the spacecraft out, and watch the images come back. And I think even they have seen various images. Of course, they get to see all the images that really are quite spectacular. And
what a time to be alive, isn't it? What a time.
Oh, absolutely. It really is a golden age of astronomy